This lesson, we're going to look at some examples that will be able to use Bayes formulas, Bayes theorems. So example 1 is say for a fixed length of time, the probability of worker error on a certain production line is 0.1, and probability that an accident will occur when there is a worker's error is going to be 0.3, and the probability that an accident will occur when there is no worker's error is going to be 0.2. They want you to find the probability of worker's error if there is an accident. So before I do anything else, I wanted to see what is given. And this wording is so long, so we're going to change that with the letter. So I wanted to say event of accident is going to be A. So I'm going to let A, letter A is going to be event of an accident. And then I'm going to let E be the event of a worker's error. Then when we're looking for probability of event A, that's something we don't know yet. It's not given. But they have a probability of event E, which is going to be this. That's going to be 0.1, right? And then that means probability of E naught is going to be 0.9 because 1 minus 0.1 gives you 0.9. And then what else is given? It also said probability of A given E is 0.0. It's a probability that occur when there is worker's errors. Probably that an accident will occur when there is a worker's error. Accident given worker's error is going to be 0.3. And then what else is given? Probability of A given E naught is going to be 0.2. That's probably that an accident will occur when there is no worker's error is 0.2. So this is all given. But what are they asking you to find? Find the probability of worker's error if there is an accident. So we wanted to find probability of E given A. So we have A given E or A given E naught, probability of E, probability of E naughts are given, but there is no probability of E given A. So then that's when you're going to use Bayes theorems. So Bayes theorem said in order to find this converted given probabilities, you're going to use probability of E times probability of A naught A given E over probability of E times probability of A given E plus probability of E naught times probability of A given E naught. So just using the formula there, then this gives you 0.1 times 0.3 over 0.1 times 0.3 plus 0.9 times 0.2, which you will get 0.143 as probability of E given A. And that's what they were asking. And that's A. What about B? B is asking find probability of E not given A. So if it's E not given A, your formula based theorems, if you wanted to use it, the numerator will start with E naught. So probability of E naught times probability of A given E naught over probability of E naught. So the first part of denominator will be the same as the numerator plus the opposite. So probability of E times probability of A given E, right? And this gives you 0.9 times 0.2 over 0.9 times 0.2 plus 0.1 times 0.3 is equals to 0.857. So the probability of E not given A is going to be 0.857 using Bayes' theorem. Let's look at another problem. This time you need to find all those probability given the conditions first. So one box has 3 blue and 2 white balls, and second box had 1 blue and 3 white. A single fair dice is rolled, and if 1 or 2 comes up, a ball is thrown out of the first box. Otherwise, the ball is thrown out of the second box. If the drawn ball is the blue, what is the probability that it comes out of the first box or comes out from the second box? So this is 2 problems. Let's give the variables so we don't have to write all those wording again. So I'm going to say box 1, box 2, first box, I will say box 1. Second box is going to be B2. And then we have a blue is B, white is going to be W. So what are we looking for? The first one, let's say this one right here. It's say what is the probability that it comes out of the first box. So we're talking about blue. So first box given blue, right? This is what we're looking for. And also second box is probability of getting second box given the blue. That's what we're trying to look for. So when I look at this example, I will have my first box and second box. When do I use the first box? Well, if I get 1 or 2, when I roll the dice, and if I get 1 or 2, I will pick out of from first box. So dice have 6 sides, 1 or 2 is just 2 out of 6 options. I will use box 1. Then rest of them, 4 out of 6 will be box 2. From the box 1, I have how many blue? 3 blue. And I have 2 white. So probability of getting a blue from the box 1 is going to be 3 out of total of 5, or 2 out of 5 getting white. From box 2, if I pick blue, that's going to be only 1 blue out of 4 and 3 white out of 4. So this shows if I have probability of picking a box 1 times probability of picking up blue given box 1 is going to be, so trying to get this one right here. That will be the probability that I'm looking for, right? That's going to be 3 out of 5, or let's change the order. So it will be 2 out of 6 times 3 out of 5, which I will end up getting 1 out of 5. And what about if I'm getting probability of box 2 and getting a blue from there, right? Blue from box 2. That's going to be this one right here. So that will be this case right there. So it will be 4 out of 6 times 1 out of 4, which gives me 1 out of 6. Right? But then don't forget the research we're doing, the testing we're doing is finding B, getting a B from box 1 or getting a B given box 2 was given. But then the question was asking, given blue, what will be the probability of getting it from the box 1 or box 2, right? So that's going to be flip incident. So in that case, we're going to use the Bayes theorem again. So the first one, Bayes theorems, I will get probability of getting B1 times probability of B given B1 is probability of B1 times probability of B given capital B1 plus probability of opposite. So it will be box 2 with probability of B given box 2, right? And this gives you this right here is this that we figure it out, which is 1 over 5. So 1 over 5 plus this is going to be that. So it will be 1 over 6. That is 1 over 5 over, it will be 6 over 30 plus 5 over 30, which is 1 over 5 over 11 over 30. And when you multiply numerator and denominator by times 30 over 11 times 30 over 11 to get rid of fractions, you will end up getting 30 over 55. And when you reduce this, 5 goes into 55, 11, 5 goes into 36 times, so it becomes 6 over 11. So that will be the probability. If you wanted to change to decimal, it will be 0.55. So if we wanted to find the probability of box 2 given blue, we're going to use the box 2 with probability of finding box 2 times probability of B come from, the blue come from box 2, right? So we start that. It means you will have the same thing to begin with it in denominator and then add the opposite, whatever the leftover probabilities, right? In that case, you're going to have 1 over 6 over 1 over 6 plus 1 over 5. So when you add denominator, it will be 5 over 30 plus 6 over 30, which is going to be 11 over 30. And if you wanted to multiply numerator, denominator by 30 over 11, why? So we can get rid of this denominator completely. This gives you 5/11 remains. And that's going to be probability of getting blue from the second box. Okay, example 3, last example from this section. It's a 2006 General Social Survey of women who are age 18 or older indicate 86% of married women had one or more children. 31% of never married women had one or more children. 86% of women who are divorced, separated, or widowed have one or more children. The survey also indicates 48% of women age 18 or older let me see. I think we're missing some wording here, saying that 48% is going to be a married woman. Okay. And 24% had been never married. And 28% is divorced and separated or widows. They want you to use E for having one or more children, F1 to be married woman, F2 to be never married, and F3 will be others. So with that information, I should be able to get probability of F1. F1 being married woman is going to be 48%. So this is survey also indicate that 48% of women age 18 or older were married. So that's the part it's missing. And it's a 24% had never been married, so it will be 0.24 as the probabilities. And it's a 28% were divorced, separated, widows, so it will be 0.28 probability for F3. And also it mentions the probability of E given F1. So E being having one or more children, that's going to be having one or more children given married. Having one or more children, not married. Having one or two children, others, which is divorced, separated, or widowed. So that's all given right here. So it will be 86%, which means probability of 0.86. 31%, which gives you probability of 0.31. 86% give you probability of 0.86. The first question is asking to find the probability of that woman who have one or more children is married. Having one or more children is married. So this is asking to find F1 given E. And this is the formula using the Bayes theorems. And that's the formula you understand. And then you add the other two cases to complete the percent, right? So then when you replace those numbers, it will be 0.48 times 0.86 over 0.48 times 0.86 plus 0.24 times 0.31. That comes from right here, right? The probability of F2 is involved. And then plus that part right here comes from this. So the probability that involved F3 is going to be 0.28 times 0.86. When you figure out numerator and denominator separately, this is the value you get. And that's approximately 0.567. Now, if we wanted to look at the B, which is looking for probability of F2 given E, we will start with the probability that's involving F2. So it will be probability of getting F2 times probability of E given F2 over probability of F2 times probability of E given F2 to start it and add them up the other two. So it will be probability of F1 given times probability of E given F1 plus probability of F3 times probability of E given F3. And when you plug in those numbers, it will be 0.24 times 0.31 over 0.24 times 0.31 plus 0.48 times 0.86 plus 0.28 times 0.86. Which is going to be the same denominators as the other one. The numerators change, but the denominator will be same because that will be the same value as this, right? This gives you approximately 0.1022. And this is how you're going to use Bayes' theorems to figure out some probabilities.